All right. Sorry for making you wait. I was in a meeting. And I wasn't looking at the clock. All right. A little bit different than what we talked about this morning. We were talking about web servers this morning. Today we're going to talk about ES6 because we definitely should. We probably have spent a little bit. We waited maybe a little too long to talk about ES6, but now's as good a time as any. Could anyone maybe guess what the date was when I first gave this lecture? Well, this is the name of the script. It was ECMAScript 2015. It was in the year 2017, probably. Early in the year. Happened to be February 14th. And I was like, okay, well, I'll just make it nice and pink and make it themed with. And then, of course, this lecture is never going to happen to be on Valentine's Day again, or the likelihood is low. But I liked the colors, and I stuck with it. All right. So ES6, there's a long history of JavaScript. It's probably older than some of you. So it's kind of an interesting history. I'll try and speak about it quickly. So who's heard of Netscape? Okay, so most of us have heard of Netscape. No, everyone's heard of Netscape. Good. Netscape Navigator was the browser back in 1994-95. This was the browser we all used. At that point, I don't even think there was a choice. I mean, there was a bit of a choice, but that was the commercial, modern browser. And they got this idea that they wanted to add a scripting language, because at that point, Java was the way that you added interactivity to your site. And so you'd have a Java applet load up, and it would be this ugly Java interface, and no one liked that. So they started off by calling the language Mocha. Then they ended up releasing the beta version of Netscape Navigator, I think 3, with LiveScript support, which was the early version of JavaScript. And then when they released the final version, they had renamed it to JavaScript. And JavaScript is named, and it's named in an interesting way because they were basically looking at this language called Java, huge popularity, and maybe trying to ride on the coattails a little bit. We'll say, well, this is called JavaScript. Java is popular. Maybe we'll get some of that popularity too. And all it's done is really made us confused, right? Because they're not related in any way, really. So JavaScript comes out in 1995, and Netscape's the only browser that supports this. And there's another browser coming around this time that wants to take over the market called Internet Explorer. And they decide that they're going to reverse engineer this language that Netscape has created and then put what they believe to be that language into the browser. And now you have two browsers that know JavaScript, right? Not quite. They were implemented differently. So if you run code in one browser, it might run different than in the other browser. And this was what we had to do for many years. Part of the reason I got out of web development was because I was just kind of sick of that. In 1997, very important step here, ECMAScript was created. So ECMAScript is actually the standardization of this language that we know as JavaScript today. So there is a group of people that get together in a council. They called TC39, I think Technical Council 39 or something like that. And they get together and decide what's the next version of JavaScript or ECMAScript look like. And then all the browsers go in and implement their version of JavaScript based on those specifications. So ECMAScript version 1 comes out in 1997, and then things kind of get crazy because you've got these people that all want to add their features into this language, and then they start arguing about that. And an entire version of JavaScript that was meant to come out, version 4, never was released as a result of this. That's what the WTF means, right? So much arguing, people with big opinions, saying, what should this language be? Meanwhile, people are still using this language and trying to push the web forward with it. And so in 2005, this little thing called Ajax is sort of defined. And the way that this works is they used this API called the XML HTTP request, which was a way for us to download XML into the DOM without doing a full refresh. And they converted that. jQuery actually was the library that included that as an Ajax call. So now you can make requests to any of your web servers, any web server on any path with any method, and you can get that data back into the browser without fully refreshing the page. So this is the birth of single-page applications. In the meantime, ECMAScript's getting released. So one of the biggest releases was 2009. That was actually ECMAScript ES5, which is what we all use in the browser today. And in 2015, ECMAScript 2015 was released with a new sort of approach to versioning ECMAScript. So they decided that in the June of every year, a new specification will be released. And by doing that, the changes every year, there's only 2 or 3 new features added. Rather than if you think about the difference between ES5 and ES6, 2009 to 2015, that's 6 years worth of changes that would go into that. So ES6 was a massive undertaking. And it meant that browsers started to take a little bit longer to support all these features because there's just so many of them to support. So I think we're in a good spot right now because we've had ES7, ES8 come out. So ES 2016, ES 2017. This year in June, ES9 would have been specified. And now it's only 2 or 3 features every year that's coming out, so the browser should have an easier time keeping up. And when I say browsers have to keep up, I mean that each browser here, I've listed the 4 major ones, each of these browsers actually have their own JavaScript engine. So I'll call the browser, the people that create the browser, the vendors, the browser vendors. And so Mozilla, the browser vendor who comes out with Firefox, they maintain a JavaScript library called SpiderMonkey. Chrome, they use V8. V8 happens to be used in Node as well. So both Node and V8, or Node and Chrome, use the same JavaScript engine to do the parse and compile stage. Chakra for Edge, whatever. I think it was actually announced recently that Microsoft is thinking about, they're going to release a Windows 10 browser based on Chromium. So it's going to be basically the same tech as Chrome. And Chromium being the Linux version of Chrome. Or like an open source version of Chrome, a Chrome browser. And then you've got JavaScript Core, which comes from Apple and Safari. So in order for JavaScript to work the same in all these browsers, all of these JavaScript engines have to implement those features in the same way to the specification. And we're finally doing that, and things are finally better. And now that browsers auto-update, our end users are getting their browser, are actually having their browsers update. So we have less of this issue where people are still stuck on a browser that's 3 or 4 years old. You're still going to need to be concerned about people that work in government, maybe, because things are so slow there. Maybe they're still on IE11, which is the only browser I really worry about still in terms of the non-modern browsers. When it comes to Firefox, Chrome, Edge, and Safari, they're updated at a pretty good cadence and hopefully automatically for users. Okay? Does that all make sense? Okay. Then there's this. We still have to deploy apps, and we still want to write our code using new features of these languages. So, and again, new features of these browsers. So we have to come up with a solution to be able to write our code in a way that we want, but still deploy that code in a way that the end user's browsers will understand it. Does that make sense? The code we write is different than the code that actually gets run in the browser, because we need to apply one of these approaches to that. So transpiling is this process where we take a file that's in ES6, we put it through a transpiler, and it comes out as JavaScript, but at ES5 only JavaScript. And since all the browsers that we use today fully support ES5, we run that in the browser, everything's just fine. And as new features get added, they could get added to this tool, and we could write that in our code, but it would still get compiled or transpiled to ES5 for compatibility reasons. So that's for language code that needs to be converted. There's also this idea of polyfills. Polyfills are a way for us to add features into a browser that didn't exist when that browser was created. So an example that I have here is this idea of JSON. Like we've used JSON parse and JSON stringify. And these functions did not always exist in the browsers. I think they were actually added maybe in ES5, so 2009. Before that, what did people do to use JSON in their browsers? They had a library for it, just like we do. We write a JavaScript library that knows how to parse JSON, knows how to stringify JSON. There we go. So browsers start to add these functions into them. And some browsers still don't support it. So what we would do is we'd create a polyfill that says, basically, if this browser does not support this feature, JSON, then let's add some script in JavaScript to create the interface, JSON parse and JSON stringify, all that code will run in JavaScript. Whereas if the browser understands what JSON stringify and JSON parse are, then it will run the built into the browser version instead. But at the end of the day, your code uses the JavaScript JSON parse or the built into the browser C++ version of it. And that switches based on sort of which user is using that browser. I know this is kind of a weird thing because we don't really need to worry about it right now because we're doing all of our development on modern Chrome browsers, we could just run ES6 in there no problem. But when we want to deploy to IE 11, we have to polyfill things like, not JSON, but promises, which we'll get into in a few weeks. The fetch API, if we want to use that instead of AJAX, there's all these things that we could actually polyfill. Okay, I won't spend too much more time on that. I want to get into some details. I know we're talking about ES6 today, but I'm going to tell you about an ES5 feature that's kind of cool. JavaScript is not a perfect language. JavaScript has gotten a lot better. And there are people out there that want JavaScript to get better, but they can't, they're handcuffed, because you can't just take features out of a language and then break half the web. That would be the result, right? If we got rid of the word var and just used constant let only, then all those applications that are relying on the usage of var, all of a sudden they break. So what we could do instead is they devised this thing called strict JavaScript. And so this is a feature you can opt into. You can say that personally, I am ready to use a stricter version of this language. That means some of the features will be removed and not available to me. But what I'm going to do is I'm going to make my file here. I'm going to tell it that it is to run in strict mode. So I'll show you kind of what that means. We create a new file here. Use strict.js. And I'm going to create a function in here. And it's going to create a variable. And console log. Oops, my var. And then I run func. And this code will work just fine, right? I can node. I can run it. I get 1 as output. Can anyone spot the problem with my code? Okay. The semicolons are they're required in the language, but they're auto-inserted. Yeah. Yeah. I'm not declaring my var, and it's you that is identifying that. But I would say that a strict mode version of this language might say that that's not allowed anymore. Whereas if we didn't, if we just said that we were going to change the behavior of this, now all those apps break. We can't do that, so we have to opt in. So I'm going to opt in and say that I will use strict mode here. Now when I run this app, we got what I wanted, which is an error. I love these things, right? Reference error, my var is not defined, and that is because, sure enough, it's not defined. I change it, I run it, and the app works again. So use strict is changing the behavior of the language, making it a little bit, it's a little bit of a higher quality language as a result, because we've removed some of the features that might be dangerous or not necessarily as useful anymore. It's fully opt-in. I totally recommend that before you submit your Tiny app, at the top of your express-server.js file, you put use strict, and then you run your app and see if you get any warnings back. Because that's actually the first thing that I do when I do project evals, is I just put that at the top of the file and see if there's any sort of, I guess, undeclared variables like this, right? All right. Yes? Top of the file. Yeah. Yeah. You can run node in strict mode. So I can say node index.js -- strict or something like that. And that would mean that all of the modules that get loaded into node would be strict as well. And that's on the server. And on the client, or in any file, you can put use strict at the top. What's also kind of cool, though, is we can have another function here. And now what I'm going to do is call both of these. And so I'm going to get that reference error still, right? So my intention here, let's say I have a 3,000-line file. And there are functions in there that I want to start to adhere to the strict rules, and some of them that I'm not ready to change yet. You also have the ability, instead of at the file level, you can do it at the function level. So if only for the scope of this function will it care about strictness, and this function will not care about strictness, therefore I get 1 and 1. And if I got rid of this variable declaration here, I go back to getting that reference error. So it's either at the file level or actually at the function level. And a process might be add use strict to the top of this function, fix this function, add strict to the top of this function, fix this function. All these functions are fixed, add it to the top of the file, and then now your whole file is strict. Does that kind of make sense? Okay. So I had to go over that. But this is why we're here, to talk about ES6 today. I think we're at the point where I would feel comfortable just changing the beginning of the curriculum to use some of these features instead. Like I think 2 years ago I wasn't, because ES6 was relatively new and not fully supported yet. But now it's pretty well supported, and I think it's less likely you find some of that legacy code. And if you did, you look up what var is, I guess. I don't know. So I'm going to still talk to you about this stuff, but I expect that at some point this will just be included at the beginning of the curriculum, that we'll just start teaching this stuff from the beginning, and then this afternoon maybe we teach other ES6 features, because what you're going to notice, Kangax ES6, I don't know what Kangax is, but, yeah, Kangax, here we go. This is the reason I say Kangax, I don't know what that means. This is ES6. These are all of the features of ES6 along the left side here, including things like const and let. And it's not only const and let that have to be supported, it's actually all of these things about const that need to be supported. So we can see that 18 out of 18, you have to actually support these 18 different features, and they kind of give you examples of what those mean here, in order for const to be fully supported. And we can see that down the line, one browser here supports none of those features, so it doesn't support const at all. And some of them, to me, it's actually a little more dangerous here, that they support 14 out of 18, of those features. So this compatibility table is telling us the current state of this feature support. And when I look up this whole list here, and I look at these modern browsers, which kind of start here, Edge, Firefox, Chrome, Safari, this is all green here. Right. And some things, for example, I noticed, I saw it in here. I saw like a 5 out of 6. Here we go. So it doesn't know if Safari 11.1 supports this feature, kind of thing. All right. So compatibility table, we have to be considering this. Those are all the features. And the ones I'm going to talk to you about today, like I said, in a future lecture, maybe we're just talking about some more advanced features of ES6. Let's start with let constant var. This is why I don't want to change it. I really like the color scheme for this. I got a function. At the top of my function, I'm going to create a variable called greeting, and it'll have the value hello. Is there any point in time in that function where I try and reassign to the word greeting? Nope. Is there any variable in this function that I do reassign to? There is one. So I is a variable that's changing. As we loop, that value increases by 1 every time. But greeting doesn't change at all. And so what const and let are doing, what const is doing is allowing us to mark a variable as something that cannot be reassigned to. So here we're saying greeting can't change its value. We can't reassign a value to greeting. Once it's set, it's set. And that's actually pretty nice, because the more things change, the more bugs we have in our code. So the more we can enforce immutability, the better off we are in terms of bug fixing and all that kind of stuff. So I think it's pretty straightforward what const means. We can't reassign. And so if I create a new function, new file here, const var let.js, I'm going to create my const var no change equals value, and then I can say no change equals not gonna work. And so when I run this, it's saying assignment to constant variable, yeah, not gonna work. So that's the unique behavior of const. Const and let have another, I guess, another quality to them that is different than var, and that is that they are block scoped rather than lexical scoped. So lexical scoped would be scoped to the function that they're declared in. They're hoisted to the top. Let and const is more about block scoping. If I just take, I don't know, some function here, and I create a var, then as far as this code is concerned, these two variables are not really different in the way that they behave. Even though var is lexically scoped and let is block scoped, they're both declared in this function, so the block happens to be the function as well, and so they're very similar. Okay, but there are situations where we have blocks like so here, the behavior is that var is brought up here, and then I is set here. So technically, this is lexically scoped as well. That it's available down here as a value, right? And so I can print out all the numbers from 0 to 10, and then I can print out whatever I was when we finish this loop, right? Got to call the function, of course. Not going to do anything otherwise. There we go. 0, 1, 2, 3, 4, 5, 6, 9, 10, 11, or 9, 10. And I'm just going to put in here, I don't know, like after, just to see. Number 10 is the one that is outside that for loop. If I change this to let instead, then it doesn't act, then it acts differently. I'm actually going to get an error now. Down here, outside of the loop, it's saying I is not defined. And so when I am not inside of this block here, which is what I is scoped to, I don't have access to I. The only way I have access to I is to make it a var. Cool? Okay. If I made this const, that's not going to work. Assignment to a constant variable. So let is not a bad option here. Var will work just as fine. Hard to say when you'd want block scoping explicitly. Can we think of what other blocks might look like? Because there's actually a few other types of blocks that we've created. Some you've created for sure, and some you have not seen yet, most likely. There's another kind of, so my for loop, I'd say that's a type of block. If, yeah, that's another one, right? So if true, if I say let I equals 1, and var I equals 2, or j. In this case, I is only accessible within this if condition, whereas var is accessible throughout. Okay. Another block. There's one. Don't bother with that, but you can do this if you want. And now I is only accessible within this block, not outside of it, but var still accessible. J would still be accessible. Okay. So these are all examples of blocks: for, if, and then this empty kind of anonymous, I don't know, naked block. I don't know what to call it. I never use it, so whatever it is. Okay, and then one more thing. Now, I said that const would avoid reassignment, right? So I'm going to take my object, and I'm going to replace it with an array. Doesn't work, assignment to constant value. Okay. Let's see. All right. So now I'm going to say, I'm going to log out obj.changeable. Okay, I get not changed. But then I'm like, okay, well, obj.changeable, what am I going to get? Is it going to be assignment to constant variable? Is it going to be just print out? Okay, maybe an error. Changed it. But I said const. It's only assignment that's actually constant. that the contents of the array of the object can still be changed even if it's assigned to a constant variable. That object is still mutatable, okay? And it's same with an array. I can still push onto an array that was marked as const, because it's not the actual data that's constant. It's the assignment that is constant. The variable cannot have a reassignment. Does that all make sense? Okay. Yeah, like I said, if I made this an array and just pushed onto it, that would work as well. Okay. So this is let constant var. You can continue to use var if you want the whole time. If you look at my code, it's 99% const, just because that's sort of my style. I don't think you need to go and make all your vars lets now. I don't think that really adds any benefit. But if you do want block scoping, here it is. Chances are you won't need it throughout this program. Okay. I don't even know if it's worth talking about this. Let me just tell you that there is a difference between for of and for in. We've used for in so far, right? What do we use for in for? Yeah, looping through objects. For of will not loop through objects. For of will only loop through what we call iterable objects. And so that object has to have a special interface to it. And the iterable objects that you'd be familiar with today, array, string. Those are two examples of iterable objects. So I can use, so if an array is iterable, then I can say item of list, and it's going to give me 1, then 2, then 3, then 4. And so that's actually pretty useful. It gives us that kind of a, we're getting the value out, though, instead of the key, right? In that case? Whereas with for in, we get the key, and then have to use a lookup to get the value. So instead of spending a lot of time with this, I'd like to replace it with a little bit of a different concept, which I think is a little bit more interesting to me. And it is this idea of destructuring. So destructuring assignment is another new feature of ES6. And there are situations where I might have an object like so. And what I want to do is I want to create a variable called a that just points to obj a. And I want to create a variable called c that points to obj c. And I don't care about b. Right? So I want to pick certain parts out of this object and then create local variables for them. Has anyone wanted to do that before? No? Maybe? I don't know. I think it's actually pretty nice because then I don't have to go and type obj a all over the place, right? So there's actually a shorthand for this. And that would do the same thing for me. It would give me two local variables, one called a, one called c, and they would point to their corresponding values inside that object. So here, this key is a. It would assign a to the value 1 to a, and then I'd now have a here. And if I console log a, don't constant anymore, then I will get 1 for this. Oops. Node destructuring. I get 1, and I can also log out c. Oh, wow. There we go. There we go. So I get 1 and 3 that way. But this is sort of a nice way to do that. And you can actually go a couple levels deep. So if this contains an object, you can destructure that object as well. You can rename during destructuring if you want. There's a whole bunch of stuff that comes with this. But this is going to be useful to you in the later weeks of the program for sure. When we get into React, this is very common. So I thought I'd show it to you now, just because for of is a bit more niche than I really care for. Okay. Now, this is great. Template literals. I really wanted to do this yesterday so bad. I wanted to use this feature so bad yesterday. And to me, this is one of the greatest kind of low-key features of ES6. Create a new one. Template literals.js. And what we're going to notice is with JS so far, we can mark strings like so. We can do it like so. And now the new way, okay. You're like, well, I don't know. Isn't it just easier to do the single and the double? or the double? And are the single and double in any way different, as far as we know? I don't think they act any different. But we actually have some added benefit by using this third backtick way of defining strings. The two benefits, multi-line strings. Try doing that here. I mean, that, as far as I'm concerned, Java's saying fuck you. So that sucks. And the same with these double quotes. I don't get to do it here either. So the only way I can actually do multi-line strings is with this new syntax. So I think that's actually kind of a bonus. And what's cool about this is I can start to define my SQL queries. Select star from table where. And I can actually do it the way I'd want to write it, rather than have it be like one long string that's hard to edit. This is kind of useful to me. Another reason I might want to do this. Oh, it's so much nicer than having to do the other way, which is, and then I get to actually see the hierarchy because I get to use indents inside that multi-line string as well. So multi-line strings, I think there is benefit to that. We also have another part of this feature where we can say, I'm going to define some variables. So I want to console log some information about our friend here. And I want to get, normally what I would do is I say name is age, right? So I'll say name is age, and this concatenates the string together. And what I do is I pass one string to console log, and it prints it out for me. So what do I call this one? Still template literals, cool. Run that, I get Susan is 72. Now, it becomes a hassle because what if I wanted to say like Susan's 72? Oops. Well, that works, but I had to do this extra piece here, which was add the backslash to escape the thing. And so now I'm actually, if I want to put quotes around stuff, that becomes confusing. Which quotes do I use to represent that this is a string? Which quote do I use in the actual string itself? Do I have to use a backslash to escape this? What's nice is that if I just switch this over to a template literal, then I get to actually tell it what things represent JavaScript that I want it to execute. So for example, name is going to be written to the string here. I can say name.s. So I get Susan 72 that way. I got to put that quote right in there. You can do double quotes, single quotes. And it's very uncommon that we do backticks, but if we needed to, backslash backtick is still going to work for us. And we run that, it still says that, right? So we can do any evaluation we want to here. Let's say we want to, age times 2 or something like that. I could do that. 52 instead. So any expression I want in here, 400 times 400, it'll evaluate that expression for me and then put it into the string. Start using these immediately. You'll never go back. Questions about that? Okay. So I've got some time for this. That's good. What time is it now? 3:42. Excellent. Arrow functions, right? Has anyone used these yet? A little bit. Did you notice any differences? Return. Well, I've got an implicit return here. That's kind of cool. So if your function only has a single expression in it, that means like usually that's one line with a semicolon at the end of it. You can have that be implicitly returned. You don't actually have to put the word return in there. See it, my third option down here? Okay, so I guess what I've got here, I've got my first situation where I've got a list and I want to map over it and I want to pass a function. That function, I can just pass it like this. We've all been doing that, and then I return value times value. So what am I actually trying to do with this code here? What's my resulting array look like? Yep. Yeah, so my result is an array, because map gives us back an array with 4 values in it still. Those values have changed, though, because they're now 1, 4, 9, and 16, because I've just doubled I've squared everything, right? So that's the purpose of this code, is to go through the array and convert it to an array of squared numbers instead. Same with the second second piece of code right here. I'm able to switch this over to a arrow function. And so we see a syntactical change here. I'm no longer using the keyword function. I'm moving to the other side of my parameters, and I'm putting the arrow there instead. So we know that one difference with arrow functions is a syntax change, right? Okay. And then we can go to even further down, and the third function there, or the third piece of code there, does the exact same thing again. It's just not using brackets around value. That's one difference. And it's doing an implicit return. Okay. So I'm going to write this 1, 2, 3, 4 dot map. I'll give it a function, take in a number, return num times num. Node arrows.js. Of course, I need to want that result, and I'm going to print it out. There it is, 1, 4, 9, and 16. So now I'm going to make this an arrow function. I will remove the function keyword. I will put the arrow in there, and I will retain the multi-line brackets that I can continue to use if I feel like it. I run, I get the exact same result. So here, these brackets, just so you know, they're only required if you have 0 or more than 1 parameter. But if you have 1 parameter, you don't need them. I don't like that. I wish it was just you need them all the time, because then it's not confusing to teach, right? So my recommendation is to maybe use them all the time. You don't have to, but maybe you want to. If this takes in 2 things, for example, it takes the index as well, I have to put parentheses around it. If I don't, I get a syntax error. Num is not defined. So I have to put these parentheses around that. Get that, I get my code back. Or it's working again, right? So this is really good. Maybe I do some other things here. I've got multi-line, that makes sense. But what if you only need one thing to happen, like in this example? Well, we could remove these braces here. And if we do that, we're going to use the implicit return behavior instead. So I remove the return. It's going to implicitly return this. We actually don't care about the index at this point. So when I run this, I get 1, 4, 9, and 16 again. A little bit nicer, 1 line, quite clean. To me, arrow functions make a lot of sense as with map, with reduce, with filter. I think that makes a lot of sense. If you're writing functions at the top level of your file, I like to use the function keyword. To me, it's a little bit more clear. I like to use function declarations that way. So then the third thing, and it's unfortunate that this is the case at this point in time, because it's going to feel a little bit overwhelming as I explain this, but there is one major difference between these 2 things, and it has nothing to do with the way it looks. It's actually with how the context of this works. Okay. So let's go over a little bit of an exercise here. Console log this dot value, right? All right. What's my output? It is that simple. 1. Okay, good. So my output is 1. And everyone see that? See how that works? Is that when I call obj.func, obj will actually be set. The context of this will be set to the object. Therefore, when I say this, it means this object. Therefore, this dot value means object.value. Cool? Is this even really that confusing? Yes, it is. Here's another one. This is where it starts to kind of fall apart. Okay. Now, if I were to run this code, other.func, what are my two outputs? Definitely 1 still, and 2. Cool. So this function here is called. It looks up this. This was set when it was called, so it should be other. So this dot value is 2. Okay. Now, I don't want to repeat my code. I have a function that looks like this already, right? So now I'm just going to create this reference to this other function that exists. What is my output now? This is where it gets tricky. One and 1. Okay. And 1 and 1 is sort of what I expect the answer to be. Because based on what we saw before, when I call the function in here, it's using this as being that object, so it would grab the value 1. And I'm calling that exact same function over here, even though it happens to be through this other object, right? But what we'd actually get in this case is 1 and 2. Okay? I'm going to save this and show you. We get 1 and 2. So we need to understand why that is. We don't have to understand why that is today, but we're going to learn it over the next. When it makes sense to teach this in a lecture, I like to do that. So I find that today, last week we might have talked about this when we were talking about objects. That might have been. I don't know if we did or not. I don't teach that lecture, but then this afternoon we talk about this. Next week when we do jQuery, there's a little bit of stuff in the assignments about this. When we get to React, we have to use this. So there are different points in the program where we have to use this, sometimes to our advantage. So I don't expect that we're going to fully understand it right now, but this is just a little bit of a step up from where we are. Okay. Let's talk about why this is happening this way. When I call a function, and that function is declared as a function like this, the context of this for that function call will be determined at runtime, not author time. So it doesn't matter where this function was declared. The only thing that matters for how this is set is how the function is called. And how is this function called here? Which object is this called on? Yeah, other. So when that happens, we look at the left side of this dot here, and we're seeing other. For this function call, the context will be set to other. Okay? Even though this function exists over here, it's how it's called that matters. So you don't know JS. Great book series. Kyle Simpson. This guy. Super smart JavaScript guy. I've learned a lot from him, for sure. We've got a book called This and Object Prototypes, and these happen to be free on Git. So as long as you don't, if you want to buy the copy, that probably helps them out. I definitely did it. But you can also get all the information for free on Git. So we'll go to chapter 1. It's called This or That. And I'm going to go down all the way to the end, and I'm going to read a little bit, an excerpt from here. So we said earlier that this is not an author time binding, but a runtime binding. Is that unclear to anyone what that distinction is? So author time versus runtime. Author is how we write the code. Runtime is how we run the code. This is contextual based on the conditions of the function's invocation. How the function is called will change the way that this context is applied. Does that make sense? Or what the value of this is inside that function will change depending on how the function is called. This binding has nothing to do with where a function is declared. So it doesn't matter that I declared the function as part of obj. It has everything to do with the manner which the way the function is called, and I called the function through other, and so that's how this is getting set. Is that all right? Okay. And you're like, what the hell does this have to do with arrow functions, right? The rules of this do not apply to arrow functions. Function expressions or function declarations like this, they have this context. Arrow functions, they use the context of this from their parent scope, from their parent context. So I could switch this over here, change this to an arrow function. What's my output going to be? What is that? 1 and 1 and 1. Okay. Damn, it's undefined and undefined. It's a good guess, though, right? Because we said that it's at the declaration, and I declared this in this object. But actually, as far as JavaScript is concerned, it's not declared. This object doesn't have its scope. So what it's actually going to use is this value up here. Because this is not a function declaration, it's an arrow function, its context of this is going to be set based on where it is created. And where it's created is actually in this whole file. And so this dot value in the file is the value it's going to use. We run that now, and we get 3 and 3. Okay. So I guess my whole point, arrow functions are not just about syntax. The context of this is also different. And that's all we have to get out of it, is that is something that we have to deal with. And we don't necessarily even really care about that for another couple weeks. But now is a good time to talk about it, because I shouldn't tell you about arrow functions and say that they're only syntax, because they really are not. There's one more small change that I will just tell you about again. Some function here doesn't take any arguments, or maybe I want it to be able to take a variable number of arguments. I'm passing it 3 parameters, but it doesn't take any parameters, right? These are the arguments that were passed to the function as an array. So arguments is an array that exists inside function declarations that gives me back, it's an array of all the arguments that were passed into it. So I actually don't really have to, I mean, in some cases I want to name my parameters for sure. Actually, in most cases I want to name my parameters. But in some cases we want a variable number of arguments, which means we can't really give them names. But we could iterate through them and do stuff with them if we wanted to. What happens if I do this, though? These are actually like arguments from, again, the parent, right? So we don't get to use this arguments word inside arrow functions either. And so that's why arrow functions are good for some things, but maybe not other things that you have to still do in JavaScript. So arrow functions do not replace function declarations. We have to use both still. And the way Vaz put it, let's get GitHub, Jensen, ES6 notes. So where's Vaz? Vaz's notes, arrow functions. Okay. Let's use the following guidelines for choosing which styles to use. Thanks, Vaz. So top level functions should use function. And that is really just, if you have a module, in that module, create your functions like you have been doing. Functions that are meant to be invoked with this context, so somewhere in that function you want to use that dynamic behavior of this for something. There are good use cases. Then you have to use a function. We don't get to use arrow functions anymore for that. And then also, functions define and pass inlines and arguments. This is anonymous functions, predicate functions, callbacks, are good candidates for arrow functions. Shorter, simpler syntax. And at that very simple level, we can keep everything on one line, not have to break things down, and it becomes a bit more clear. So keep this in mind when you're choosing, and just remember, you can't just You can't just replace every function with an arrow function. It might not work the same anymore. All right. There's lots more to ES6. I hope that eventually I can kind of convert this over and talk about some of these things instead. I know that we'll get into class syntax for React. We'll get into promises week 4, day 4. Yeah, week 4, day 4. I talked about destructuring assignment. We have modules on here. We've been using modules already, right? Only in Node, though. And Node is using something called CommonJS modules, which is a community-developed module system. When we talk about ES6 modules, that's actually the language now supporting that. So in the browser, we can do import something from a library, and we can do export something from a file, and that would be the new syntax for doing modules. But for or for Node, we still continue to use the old CommonJS format with require and export module.export. Anybody curious what enhanced object properties are? Yeah? Okay. A little bit of a... So I have this obj, right? And I want to add things to it. For example, let's say I have this variable, my key is equal to A or something like that. So I can say obj key is equal to 1. And so now when I log this out, oops, I get A1. Okay. So I was able to take this dynamic property, or this dynamic key here, and use it to create a new key in my object, but I had to do it after I initialized the object. What enhanced object properties are? It's the ability to, instead of having to create the object and then add the key, we can create the object and add the key at the same time here. So we wouldn't need to do this after the fact anymore. And those are enhanced object properties, and it's not something we had before. We didn't get to use null as a key before. It kind of wouldn't let us, right? So I don't think so, at least. Kind of a cool feature. I've definitely used it before. There's much more. You'll want to do some research on this. Any questions? How do we feel about that? Welcome back, everyone. Okay. If you need anything, message me on Slack. I'll send out the notes. Yeah, enjoy. Enjoy those template literals, seriously.